Today we'll be performing the pressure and volume investigation. The directions. As you've discovered, with the balloon in the bell jar, pressure and volume have an indirect relationship. You observe the pressure surrounding the balloon decreases as air particles were removed by the vacuum pump. As a result, the air particles inside of the balloon were able to spread out, which caused the volume of the balloon to increase. Now it is your turn. Use the materials provided to investigate how pressure and volume relate. Your materials are the syringe apparatus, or also known as the Boyle's law apparatus, a triple beam balance. We don't need a triple beam balance because the assorted masses have the mass on top. We have a 500 grams, another 500 grams, 1,000, 1,000, 1,000, 1,000 grams, and also 1,000 grams. So the rules are, as a group, develop your own procedure. Spaces were provided for you to write your procedure, that's down here. You must use all materials in your investigation. You must create a data table to tabulate the data. You must create a graph to display the data. And finally, you must formulate an explanation as to why this phenomenon occurred. Here's what a quality procedure would look like. Step 1, gather the syringe apparatus and assorted masses. Step 2, reset the syringe apparatus to read 35 cubic centimeters. Step 3, add a 500 gram mass to the top of the syringe apparatus. Step 4, record the mass on top of the apparatus as well as the volume of the space inside of the syringe on the data table. Step 5, repeat steps 2 through 4 and replace 2 500 gram masses with 1,000 gram mass where necessary. Yep. And one more. Step 6, our last step is always going to be return all materials. So step 1, you're going to gather your materials, the syringe apparatus, and assorted masses. Step 2, reset the syringe apparatus to read 35 cubic centimeters, right there at the top. Step 3, you're going to add a 500 gram mass to the top of the syringe apparatus, one at a time. Step 4, you're going to record the mass on top of the syringe apparatus, as well as the volume that the cylinder reads, the syringe reads. And you'll record that on the data table, which we'll make. Step 5, you're going to repeat steps 2 through 4, and you can replace one 1,000 gram or 1 kilo mass for 2 500 gram masses in order to save space. And step 6, we always clean up our materials when we are done. So here is the data table. What we're going to do is we're going to have the mass, which, since we're putting the mass on top of the syringe apparatus, the mass will represent pressure. And the volume of the syringe has graduations, which represent volume in cubic centimeters. So we have volume in cubic centimeters. So that is going to be our data table. Then we have our trial. 1. So with 0 mass on it, let's reset the syringe apparatus. With 0 mass, we should be at 35 cubic centimeters. So the top of the plunger should read 35 cubic centimeters. So 0 grams, 35 cubic centimeters. Trial 2. Let's put 500 grams on there. And if we put 500 grams on there, let's reset this. We have 500 grams on there. We're still at 35 cubic centimeters. Try again. Trial 3, I'll just put a 3 there. Let's add another 500, so let's do 1,000 grams this time. Make sure we reset 1,000 grams. And now we're down to 33 cubic centimeters. So 1,000 grams is 33 cubic centimeters. Trial 4. Let's add another 500, so 1,500 grams. We're at 29 cubic centimeters. Trial 5. We'll add another 500, so we'll have 2,000 total. Let's make sure we reset to 35. Now let's put the 2 on there. Let's balance the weight so the weights don't fall off, the masses don't fall off. And now with 1,000, we're at 27 cubic centimeters. Trial 6, let's do 2,500. So we'll add another 500. We're at 25 cubic centimeters. Let's do one more over here. Trial 7. Oh, we lost the weight. Trial 7 is going to be 3,000. So let's reset to 35. 1, 2, 3,000. Try to balance them off so they don't fall off. And we're at 23 cubic centimeters. Hopefully you're noticing a pattern. Let's go, let's make a new data table. We'll do trial 8 down here. Remember, we have the mass and volume. Let's do 3,500 grams. So we have the 500. looks like 21.5 cubic centimeters. Trial 9. Let's go 4,000 grams. Try to hold it a little bit in place. You don't want to affect the mass, but you don't want it to fall off. Now write 20 even. Trial 10. Let's go another 500 grams. Try not to affect it, but try to hold it in place. Now we're at 18.5. I'm just going to pull this off so it doesn't fall. Now pull all of them off. So 18.5 at 4,500 grams. So now we'll have 5,000 grams. That'll be trial 11. I'm going to use this big flat guy. Let's first make sure we reset at 35 cc's. So 1,000, 2, 3, 4, and 5,000 grams. We have 17.5 cubic centimeters. 17.5. That is not going to stay. Let's keep going. 5,500 grams, trial 12. $16 cubic centimeters. And we'll try one more after this. 16 cubic centimeters. And finally, trial 13. Lucky number 13 will have 6,000 grams. Let's reset our syringe apparatus. 1,000. 2, 3, 4,000. 5,000. 550, 6,000, and we have exactly 15 cubic centimeters. 15 cubic centimeters. Thank you very much for joining the Pressure and Volume Investigation Lab. I hope you learned something today. Please join us again soon.